Hi, Dr. Mamari, one more time. I hope that you listen to this video before you write the report or answer questions for experiment 10, because they both come with the same week. Normally at Central Campus, we use these two experiments in 1 week. So the theoretical value for molar mass of the unknown A for the last experiment was 74. 74. So just to let you know that if you are missing from that video, hopefully you get this information from your professor, or you will get it from the video as soon as you watch this video. So 70.74.08 gram per mole is the theoretical value for molar mass. For experiment 10B, because you have another unknown here. I don't want you to get confused. This is for experiment 10B, but is reported here. Hopefully you get it before you worry about it. Okay, for experiment 11, in experiment 11, we are using colligative properties. So based on the colligative properties, what are colligative properties? Colligative properties, those are properties that depends on the number of particles associated with that solution. So colligative properties, it could be boiling point elevation, freezing point depression, changing osmotic pressure. So these are some of the colligative properties, and it depends. Let's say you have the boiling point for water is 100 degrees Celsius. You add salt to it, the boiling point is going to increase. You add salt to water, freezing point is going to decrease. And you probably have experience, like if you want to make homemade ice cream, you add salt to the ice water, or you add salt to the ice mixture in order to provide lower temperature, or when they want to prevent like freezing of the road, they spread salt on the street. It lowers the freezing point. From the fact that how much is going to lower the freezing point, you can extrapolate, or you can use that information in order to find out what was the molar mass of that compound. That's the second method to measure experimentally molar mass of unknown sample. One was if the sample is volatile, you can change to gas and use the experiment 10B to measure the molar mass. The other one in this experiment is to use the freezing point depression for a compound that is soluble in our solvent. So we measure the freezing point for the solvent first, then we add solute to it, we add our unknown to it, and we measure the melting point again. The melting point or the freezing point, which is the same thing, is going to depress. So change in freezing point is directly related to number of particles. Number of particles, it depends on the mass, and it depends on molar mass. So the smaller the molar mass is, you get more number of particles, or is related. So when you are using your calculation, when you have the number of moles, then you can you have the mass of the unknown, you have the number of moles. Just like last experiment, you can calculate the molar mass. So if you're looking at the theory for this experiment, or theory or the background, the theory could also be explained by your professor. Whoever is teaching the course can explain this again, if it's me or someone else. So basically, it's talking about colligative property, which we talked already about it, and the vapor pressures and other properties, colligative properties. So what you do, you find the freezing point for the solvent. you find the freezing point for your solution. That means after you add the solute, the change in freezing point, delta TF, is going to help you to find the molar mass. The changing freezing point then is going to be used to find the molality. Lowercase m is molality, capital M is for molarity with the R, molality, which is lowercase m, and molality with the L is number of moles of the solute per kilogram of the solvent. So we are going to find the freezing point for solvent, freezing point for solution. You subtract, you get the delta TF. Kf is a given number, is a constant or molar freezing point depression constant, is a molar freezing point depression constant. This depends on the substance you are using. If you are using like benzophenone, this number is going to be 9.80. If you are using a different value, it's going to be different substance is going to be different value. For the purpose of this experiment, for benzophenone, we are using as the solvent. The value for Kf is 9.80 degree Celsius per mole. So you have the value for K, you find delta TF experimentally, you can calculate the molality. And because molality is, it can give you the number of moles, so you find the molality, then you use the molality to find number of moles, because molality times kilogram of solvent would give you number of moles. When you have the number of moles, then you can divide the mass by number of moles in order to get the molar mass. So the calculation here, it shows the steps for calculation is showing you have to exactly find the molar mass. But I also explained, because there are three formulas I'm using. These are TF and TI, final temperature, or the freezing point for solvent, freezing point for solution. So the two temperatures that you are getting by experiment, you find delta TF. Kf is a given number, you find m, lowercase m. You find when you have the lowercase m, you plug in this formula. Because you have the kilogram of solvent experimentally, you find moles of the solute. When you have moles of the solute, molar mass equals mass over number of moles. So you have the number of moles, you can calculate the molar mass. So, but here are the steps for you, okay, for you to do the calculation. The setup is very similar to the setup for experiment 10, part B. We have the boiling water bath. We are going to heat up the sample to melt completely, to change to liquid, then we slowly let it cool down, and we record the temperature for freezing point by following the procedure. Okay, let me go ahead and start the procedure for this experiment. That is the major purpose or main purpose for this experiment, is for you to be able to collect your data. So I emphasize more on the procedure part of the experiment and the data collections, because if you are learning the experiments or you're taking the course by distance learning remotely, you are not here to perform the experiment to record those data. So those data is explained during the video, and you watch the video carefully, you record your data, then you can complete the data sheet and submit it as assignment to your professor. Okay, procedure for this experiment. I have to be careful with the steps and the procedure, and also I have to look at the data sheet to see what you actually need in order to record in your data table, so you can do your calculation and complete your data sheet. So first, we need the mass of empty test tube. So we have a balance here. We are going to this is what I'm going to do. I can't leave the test tubes on the, especially after I have the benzophenone in there. So I'm going to leave a beaker and place the test tube inside the beaker and measure the mass 24.200 gram. This is the mass for empty test tube. Then we need the mass of the test tube with the benzophenone. We want about 10 grams, so I'm just going to add enough to make it 10 grams. Of the benzophenone. So we have the mass now 34.249 grams. This is the mass of test tube with benzophenone. With benzophenone. Then we place the test tube in hot water bath. We place the test tube in hot water bath. We want to melt the benzophenone. We heat it up until it is completely melted. We can use the digital thermometer here. The digital thermometer measure the temperature of the benzophenone. If I measure the temperature that is going to, the sample is going to melt entirely, it could be close to the melting point, the actual melting point, but it's going to carry experimental error because if the heat is not distributed evenly or if the sample, one part of the sample is more condensed than the other. So it gives me approximate number, but it's not going to give me the actual number. So what I do, I melt it completely, then I let it cool down in order to freeze again. And at the time that I can't move this thermometer or the stirring rod, I can record temperature, or when the temperature stays constant and following the procedure, when it reaches a plateau, then I can record that temperature as the freezing point of solvent. So we have to let it cool down, and occasionally I'm going to occasionally stir it, make sure that it's even cooling, and we are going to wait for it to freeze. There is a term when you read the experiment or the procedure, it's like a super cooling. That happens often with benzophenone. Before it melts, it gets even colder than the melting point. Then the temperature rises back up. So we have to look for the temperature that stays. It goes down and it comes up again. That will tell you the temperature, what is happening. Right now it's 65. It still is liquid. It's too early, but I'm going to show you step by step what is happening. So I have the temperature still at 63, and the sample is liquid. So when we are looking for the temperature that benzophenone is going to freeze again. What's important for me is to see the solid, or I cannot move the thermometer probe or the stirring rod. If I'm using the thermometer probe in replacement of the stirring rod. It's 58 and still nothing. While it's cooling down, I need to measure 0.8 gram of the unknown. I'm using unknown A again. So I'm using unknown A. So I'm going to measure 0.8 gram of the sample while this is cooling. So I could have my chemicals ready for the next step. Let me see which unknown I'm taking. 52 and still is liquid, so we're just going to be patient and wait until it cools off. Definitely solid at room temperature because we started with solid, so it will freeze before it reaches 25, which is the room temperature. Trying to find what is the theoretical value for melting point of benzophenone. It doesn't show me, so just search quickly while you're watching the setup for me. Getting close. Okay. The temperature went to 47. It came back to 49. So you see that's changing to solid. Add some water to this. We need it for next step of the experiment. I didn't turn off. Okay. Theoretical value for freezing point is supposed to be 49.9, but the value shown here is slightly higher and the sample is frozen. So I'm going to record what we have here, but it could be the thermometer. Freezing point of benzophenone. Freezing point for benzophenone. $51.8. Let's see. Okay. Now we are going to add the 0.8 gram. So the next step, we are going to add the 0.8 gram of the solute, and I choose the unknown number, unknown letter C. So when I add the solution, when I add the solute, now I have a solution. Solution doesn't always have to be liquid. You could have also solid in solid solution. We are going to place it back in the hot water to change to liquid. So when we add the solute, freezing point will be depressed. So basically it's going to freeze at a lower temperature. I don't want to increase it too high because then I have to spend time to get it lower. Just want to get it high. But it has to dissolve. Okay, it dissolved completely. We're going to leave it out for cooling down. I don't need the Bunsen burner anymore. I'm going to turn it off and wait for solution to freeze. I'm going to wait for the solution to freeze. We can place in like room temperature water, or we can just give time for temperature to drop. temperature reached to 43 and still is in liquid. That's what I mean by freezing point depression. So if the solvent, which was benzophenone, freezes at 52 using this thermometer, probably had some error. Solution, it freezes at much lower temperature. We have to wait because, as I said, it could go low and then it goes back up. When it stays stable, we record the temperature. When it goes down and it goes back up, that means that it went through super cooling process. The temperature is lower than the freezing point, the solution still is in liquid form. Okay. Freezing point of solution is 45.8 degrees Celsius. From the data sheet, if you have the mass of the unknown, the letter for unknown was unknown C. You have the mass for the unknown. You have the mass of the benzophenone in kilograms. So you basically subtract the test tube, mass of test tube from test tube plus the benzophenone. You get the mass of the benzophenone. You have mass of the unknown. You have the freezing point of the benzophenone. That was the first number, the 52.8. And then we have the freezing point for solution. Then you can calculate the delta TF, and from delta TF you could calculate the number of moles. You find the molarity, you find the number of moles, then you find the molar mass. So the calculation is also is shown here. Okay, that was experiment 11. So I am going to stop the recording here. The purpose of the experiment again is for you to collect the data, and with the data collection you are going to measure the you do your calculation and submit the data sheet to your professor. If your professor is me or someone else, it doesn't matter. So you have the collected data. Thank you. End of experiment 11.